open your books to page 291 and take out your yellow exponent graphic organizer. We are learning lesson 19.2 today called negative and zero powers. So we're going to cover both of these rules. So the first learning target is understand what is meant by negative and zero powers. And we're going to simplify expressions or problems involving exponents. So question 1, we see another table, and the directions say write each quotient in expanded form, like we did earlier this week, and we're going to simplify it. So this first one has been done for us, but let's talk through it. So in the numerator, we have 2 to the 5th power, which means 2 multiplied by itself 5 times. So it's written out for us. In the denominator, we have 2 to the 8th power, which is 2 multiplied by itself 8 times. And that's written out in the denominator for us. And then when we're dividing, just like before, we're going to cancel out the 2's in the numerator and the denominator. So this 2 cancels with that 2, and 2 divided by 2 is just 1. These cancel. So every 2 in the numerator cancels out. It's gone. So we need to use this 1 here as a placeholder in the numerator. And then in the denominator, I have 2 times 2 times 2, which is 2 cubed, or 2 to the 3rd power. Now, if we think back to our quotient rule, and we can look at our note sheet to help us with this, when we're dividing, we keep the base, so the base is 2, and we subtract the exponents. So our exponents here are 5 minus 8. So that's written out in the 3rd column for us. And 5 minus 8, we're subtracting a bigger number, so that would be negative 3. So it's 2 to the negative 3rd power. But that looks different than what we wrote here. So as we keep going, we're going to talk about why one of them says 1 over 2 cubed, and the other one says 2 to the negative 3. Interesting. Okay, let's keep going, and let's see what happens here. So let's look at the 5s. 5 cubed is 5 times 5 times 5. In the denominator, 5 times 5, there's going to be 6 total. Perfect. And then let's cancel out. So these two 5's cancel, and they cancel, and they cancel. So in the denominator, in the bottom, I have 5 multiplied by itself 3 times. So my base is 5, my exponent is 3. And then I need a placeholder in the numerator, so we're going to put a 1. 5 divided by 5 is 1, so we're going to put a 1 in the numerator. But let's think back to our quotient power. And remember that we keep the base, so we keep the 5, and subtract the exponents. So 3 minus 6 is negative 3. So in a little bit, we're going to talk about what's happening from here to here. So right now, what I want you to do, just like the 5's, is go through and do the A's. So pause the video and I want you to finish the A's, and you can also do the X's as well. You can do it. So cancel out my A's. In the denominator, I have A, 1, 2, 3, 4, 5 left over, so a to the 5th power, and then I need a placeholder. But let's look at our first column. This is a fraction, so we keep the A, and we subtract 3 minus 8. Type that into your calculator if you need to. 3 minus 8. We're going to keep the sign of the bigger number, so it's negative 5. The X's, 4, and then we have 10, and let's cross out the ones that cancel in the numerator and the denominator. I have X, 1, 2, 3, 4, 5, 6, multiplied by itself 6 times. And in the numerator, I need a placeholder of 1. So let's put the X here. 4 minus 10 gives me negative 6. Okay, let's take a look at what is happening from here to here, or from here to here, because these go hand in hand. So what's the difference? What do you notice between these two? One's a positive exponent, one's a negative exponent. My base is the same. Notice I have 2, 2, 5, 5, A and A, X and X, so my bases are the same. And the ones in the middle column are fractions. They all have 1 on the top, and they have positive. So here's the deal. Here's our rule. It says, based on the pattern you observed in question 1, write the missing exponent in the box below to complete the negative power property for exponents. So imagine that this is similar to what we just did above. So see how it says 1 over a to the 5th power? That equals a to the negative 5th power. Or 1 over x to the 6th equals x to the negative 6th power. So what do you think we would put in this little box? 1 over a to the n equals a to the negative n. We cannot have negative exponents. It's just a rule that they made up a long time ago. So if I have a negative exponent in my answer, it's not allowed. So what we would need to do is take it and turn it into something that looks like that. Take it and turn it into something that looks like that. This needs to look like that. Negative exponents are a big no-no. So let's add this to our graphic organizer, your yellow paper, and then the more examples we go through, hopefully the more it's going to make sense to you. So in the verbal description box, a negative exponent becomes a reciprocal. If you remember the word reciprocal from previous lessons, that's when we flip the fraction. So whatever is in the numerator goes to the denominator. Whatever is in the denominator goes to the numerator. If it's not a fraction, we have to make it a fraction. But when we do that, we turn it into a positive exponent. So, for example here, if I have a with a negative exponent, it's not allowed. Okay. Currently, it's like in the numerator of a fraction. This isn't a fraction, but remember, everything could be divided by 1. Okay? So what we need to do is we need to take this and move it to the bottom or move it to the denominator. And when we do that, it turns into a positive n. And then I need a placeholder of 1 in the numerator. Or if I have 1 over a to the negative n, that's not allowed. We cannot have negative exponents. So we need to move this up to the top into the numerator and turn it into a positive. And again, if it helps you, you could put a 1 underneath to show that you've moved it. So let me give you an analogy. Here's my fraction. If I have something in the numerator that is negative, think about this living upstairs, and it's not happy. It wants to move down into the basement, down to the denominator, and it becomes happy. It becomes positive. So when I move it, I turn it positive. Or, let's say we have somebody living in the basement, and they're unhappy, meaning they have a negative exponent. We need to move them. We want to move them up into the numerator, and when we move them, they become happy, they become positive. So let's do some examples in the example box on our organizer. So if I have 3 to the negative 4th power, currently that's upstairs or it's in the numerator, and it's negative, it's unhappy. So I need to take it and move it downstairs or into the denominator and turn it positive. Okay, next example. If I had 8y squared x to the negative 3rd power, what currently has a negative exponent? Just the x cubed. Or sorry, just the x to the negative 3rd. 8 is happy where it's at. Y squared is happy where it's at. So the only thing that we need to move here is this x to the negative 3rd power. We need to move it downstairs into the basement, into the denominator. So I'm going to leave the 8 and the y squared alone because they're positive, they're happy where they're at. But x moves downstairs, and when it does, it becomes positive or happy. All right, one more example. You should have room in your boxes because they're a little bit bigger than mine. And let's do 5x to the negative 4th power over 10 y to the negative second power. So I have two numbers out in front, two coefficients here. I have 5 and 10, and this is a division problem, so I want to divide. What is 5 divided by 10? Go ahead and type it into your calculator and write down your answer. It's 1/2, 1 over 2. Okay. You cannot have negative exponents. So this x is in the numerator, it's upstairs. I'm going to move it downstairs and turn it positive, make it happy. Y is currently downstairs, it's negative, it's unhappy. So we're going to move upstairs and make it positive or happy. So this right here would be my final answer. Okay, question 3. Now that we've talked about negatives, let's talk about a 0. So I have 2 to the 4th power over 2 to the 4th power. So expand that out. We're going to write 2 times 2 times 2 times 2. And then just like before, they cancel. It's just 1 times 1 times 1 times 1. So my answer here is just 1. But if we think back to our quotient rule, and we can look at our graphic organizer, when I have a division problem, I subtract. So 4 minus 4 is 0. So it's 2 to the 0, to the 0th power. All right, let's write out the 5s. 5. There's 6 of them. And hopefully we're going to start seeing a pattern here. So 5 divided by 5 is 1, 1, 1. They all cancel each other out. So we're left with 1. But then think, what is 5? And then 6 minus 6 gives us 0. Go ahead and do the A's. Cancel them out. What are you left with? And what's the single power answer in the third column? They all cancel, so we're left with just 1. When it's a division problem, I keep the base, which is A, and I subtract 3 minus 3, which is just 0. So let's take a look at the pattern here. This equals 2 to the 0. This equals 5 to the 0. And this equals A to the 0. What? So based on this pattern above, what do you think goes in this box below? This is called the 0 power property. So A to the 0 equals 1. 5 to the 0 equals 1. 2 to the 0 equals 1. So A to the 0 equals 1. That's our pattern here. Anything to the 0 power equals 1. Banana to the 0 power equals 1. 100,000 to the 0 power equals 1. So on our note sheet, let's fill that in. Anything to the 0 power is always, always 1. So A to the 0 power equals 1. That's the symbol straight from our book. And then let's walk through some examples here. 2.75 to the 0 power. That equals 1. A squared, B cubed, C, all raised to the 0 power. Since everything is being raised to the 0 power, it's 1. And the last example here. 5x to the 4th power, y to the 0 power. Try this question. Come up with your answer. What is the only variable or the only letter being raised to the 0 power here? Just the y. So this equals 1, but I'm still left with 5x to the 4th power times 1. So 5 has an exponent of 1. X has an exponent of 4. So those need to stay in my answer. The only thing that cancels out is y to the 0 power. That's the only thing that turns into a 1. So my answer is 5x to the 4th power. So back in our books, on page 292, you're going to see question 5. I want you to try questions A, B, C, and D. You can do it. So remember our rule, we cannot have negative exponents. So this needs to move to the denominator of a fraction. Look at your organizer to help you. So when I make a fraction, 2 has to go in the denominator or downstairs in the basement. And when we move it, we have to turn it into a positive. And then I need a placeholder in the numerator. So it's 1 over 2 cubed. Question B, you could do this in 2 different ways. Here's what I'm going to do. I am going to do the fraction or the quotient part of the problem and then clean up my negatives at the very end. So think about it this way. If you're baking a cake, or making cookies or whatever, I always do all the baking first, doing all the ingredients, all the mixing, then put it in the oven. And at the very end, my very last step, while it's baking or cooking, that's when I clean up. So that's how I want you to envision or think about this negative property. Okay? I want you to think about doing the properties that we learned, whether it's multiplying, so we add, or whether it's subtracting and we divide, whatever. Do those first, and then at the very end, if we happen to have any negatives, we're going to do the cleanup. So if I look at letter B, I see a fraction, a quotient problem. So I look at my notes, and it says to divide. I keep the base, so my base is 10, and then it says subtract the exponents. So I'm doing 2 subtract a negative 2. Well, 2 negatives make a positive. So this becomes 2 plus 2. And what is 2 plus 2? 4. So 10 to the 4th power would be my answer here. Now, if you wanted to, you could do this question a different way, so let me show it to you. You could take this and move it up, and when we move it up, it becomes positive. Well, now this is a multiplication question. And if I look at my notes, it says to multiply, I keep the base, which is 10, and I add the exponents, which is 2 plus 2, and I get 4. So we got the same answer. We did it 2 different ways. This written in green is the way that I usually do it. Letter C, 5 to the 0 power. Anything to the 0 power is 1. So I kind of think of that being gone, and then I'm going to take this negative and get rid of it. So clean up the negative. So what we need to do is we need to move it to the denominator, to the bottom, make it a positive, and then I need a placeholder in the numerator. So 1 over 3 cubed. Letter D, the easiest one up here. Anything to the 0 power is 1. So my answer for letter D is 1. I'm going to skip example A. What I would like you to do on the bottom of page 292 is I want you to go through and I want you to try to do A, B, and C. Use somebody next to you if you need help, but I want you to complete A, B, and C. You can do it. Use your exponent organizer with all the rules on it.